Say whatever I want.
So let's talk about our last endeavor into scatterplots. Today we're going to talk about the trend lines, which is taking a scatterplot, which is a large conglomerate of data, and if you can find a linear association, whether it's positive or negative, from that you can make a trend line, which is a line basically dividing half the data above it and half below it. Does that make sense? And following the data. I did have one student one day do a completely horizontal line. And he said, well, half it's above and half's below. No, that's not quite what we meant by trend line. A trend line follows the data. But it worked. It's just not a trend line at that point. It's just a divider. So we're looking for a line like we did with the other one where we could say miles per gallon. The heavier the vehicle is, the worse the gas mileage. And that makes sense if you think about it. And that's why Ford introduced the aluminum beds. Why did they do that?
To make it lighter, more gas mileage on the.
Because U.S. regulations require. Why are you talking about something else?
I'm talking about this, just in a different form.
U.S. regulations require that manufacturers make the cars more economical gas mileage wise, right? And the only real way to do that, we've kind of reached the top end of motor development, and the standard cam engine we have, which is the V or the straight where it's running off a cam, or even the rotaries, if you know anything about Mazda and some of those others, they actually have rotary engines. Within those two categories, we've kind of reached the top end of performance to gas mileage. The only way to make the vehicles better gas mileage is to lighten them. To that end, if you don't know, Bugatti made one that's a complete carbon fiber car. The seats sit in it, and you cannot adjust the seats at all. That way you get rid of all that hardware, and the car is super light, but it'll do close to 300 miles per hour.
Does it glow?
Not the fastest.
It doesn't matter. It goes by so fast you can't tell if it glows.
No, isn't it like blue?
No, it's carbon fiber black. They didn't put any paint on it because paint adds weight. The car is literally focused solely on that.
You know what?
And with that, they could get some great gas mileage, even though the monster engine they were in it wasn't in any way toned for gas mileage. Yes.
I'm letting you know, if they wreck that car, it's gonna be gone. There's not gonna be a car. It's just
Well,
gonna be five rushes.
it is all one piece. So we can use trend lines to find things like that. So here we're going to make a scatter plot. And you made a couple of those in your homework, a couple of different ones. I love the one that's just basically a bar type graph. And it works. So here we're going to make a scatter plot. We got some data saying running distance versus time. So the first one is 4 miles in 30 minutes. So we go 38 minutes.
That's 38 minutes.
4 miles ran in 38 minutes. Since each of these tick marks are 5 minutes, right? 38 somewhere around there. 2 miles took 25 minutes. That's more like me. 1 mile took 7 minutes. That's me if there's a bear chasing. That's about it. Or somebody just told me cookies are ready. I will boogie if cookies are ready. 2 miles in 16 minutes. That was me 20 years ago. 3 miles in 26 minutes. 5 miles in 55 minutes. 2 miles in 20 minutes. Because that's the requirement. 4 miles in 45 minutes. And 3 miles in 31 minutes. So I'm going to ask you, first of all, is this a function?
No.
Why is it not a function? Because look at this. We've got an input of 2 miles. Are all the outputs the same? No. So we know this is not a function. That kind of goes back to it when we're looking at it. The minute you start seeing things stacked on a graph, think to yourself, not a function. So the next thing we're going to do is we're going to draw a trend line. To do this, we're going to make a line, and like I said, it doesn't count to do half the points above and below by going Horizontal. It's a great idea, but it kind of convolutes it. So we're going to put a line that roughly half the dots are above and half the dots are below. And I will tell you this. This is definitely a proportional trend line, isn't it?
Yeah.
Because here's the point. If you're running 0 miles, how long does it take you?
0
minutes.
0 minutes. It's always going to end that way. That's one we can guarantee. And that's more like TV remote like me. 0 miles, 0 minutes. Did it. Did it. Did it. What you watching?
You
Nothing.
My TV remote.
Okay, so I got roughly half the dots above and half dots below. Does it have? Is any one of us here going to have exactly the same trend line? No, not doing this by hand. I will tell you this: if you go to college, and this is part of something called statistics. So basically, 8th grade math does several intros. You've done an intro to algebra, which is equations and all that. We've done an intro to geometry, which is where we looked at volume, and we're going to do more with angles. This is an intro to statistics. So in the state of Texas, they said, let's introduce our 8th graders to several things they'll see in life. If you, in your college degree, if you take 6 hours of statistics,
only 6 hours.
you can apply for a job that includes the title analyst. Which means, if my job is business, I get paid, right? If my job is business analyst, I get paid more.
So I just got to take 6 hours of something.
It's one of those great things. If you take 6 hours of statistics, you can tag on analyst.
So that's 1 day of statistics.
No, when 6 hour college hours means 2 separate classes, full semester on. Close your mouth. All right, so we drew our line, right? We didn't really have any outliers in this one, right? Everything there wasn't like this speed demon. I hate those people.
Me, Chris.
I got in trouble. I got in trouble in the army when I got to Panama the first time, and we were running. I didn't realize the course was really long, and if in Panama the air is almost solid water, so running is a unique experience. Even though you're at sea level, it's kind of like you're being liquidated as you run. And this one guy, he ran, we're doing 2 miles, he's done in like 11 and a half minutes, and he's standing up there cheering, come on, Sergeant, only a little bit. I'm saying, shut up. I'm running, I'm hating, and I finally used a bad language there, which got me in trouble. Stop cursing out the other sergeants. So, there's always outliers, especially running. There's always that guy who finishes. They tell you guys go out and do a mile, and there's that one person who's done like in 3.5 minutes, and they're annoying you. So now, let's write an equation for our line. You're that person, by the way. So let's write an equation for our line. Chris, you're that person?
Yes. Always.
So, what kind of equation are we going to be writing? Is it y equals mx plus b? Or is it y equals kx?
Y equals kx.
Yeah, we're really writing a y equals kx. This is definitely a proportional in that if you run 0 miles, it's 0 minutes. It's definitely going to come to that. So let's find something that looks roughly like a lattice point, which is kind of what I've got here that looks, and these are going to definitely be more guessy, aren't they?
Yeah.
Why?
Because
It's a trend line. If we're using software, it'll give us a perfect one. But we're not using software, we're using really software or pencils. So, remember, it's rise over run, right? So what's the rise?
2.
Oh, come on.
1.
Right. What do you mean 1?
Rise 10, run 1.
Same thing.
Come on. It rose from here to here, 10. Because each of these are 5, right? It rose 10. How far did it run?
1.
Well, there's 2 markers.
20.
If there's 2 markers, is it still only 1?
10.
It's still
It's still 1 because the marker here is for a half, right?
Yeah.
So it's still 1. So 10 over 1 equals
10.
10. So the equation here is y equals 10x, which says if I'm sitting at I don't know, the 3-mile marker on this race. Rayden's sitting at the 3-mile marker, and he hears somewhere in the distance the gunfire go off to start the race. He's got to figure out when he needs water. So he says, well, y equals 10x. I'm at 3 miles. I should see people around the 30-minute mark, right?
Yeah. Sure.
So a couple minutes before, maybe it says 10 minutes before that, I'll go ahead and put water out there. Sorry, Chris, you're getting no water as you pass by at 15-something. Rayden's like, sorry, dude. Water at the next station. Don't run so fast.
So fast.
So, but Rayden knows that around 30 minutes is when he's going to see the most of his runners, right? He can have a couple water out there before that, but really his biggest group is going to come in around the 30-minute mark, and then it's going to taper off, right? Yeah. So he can calculate and use that. Let's look at this trend line in number 2 here. It says, draw a trend line. Well, we've got a scatter plot. What is the first thing you notice about this scatter plot, Will?
There's
Well, what's the first thing you notice about this scatter plot?
It's a positive.
It is it's definitely a positive. Is it roughly linear? Okay, help him out.
It's scattered.
I know.
Help him out. What else do you notice about this plot?
It's a scatter
Well, we've said that. Catch?
Outlier.
What do you mean?
There's an outlier on like in between 18 and.
Yeah, this guy way up here. Yeah, that's definitely an outlier. We'll go ahead and label that. It's definitely kind of lying outside the rest of the data. So we're going to do it, and we identify it, and then we ignore it. And we don't make it part of our data. Now be careful if you try and make everything an outlier. At that point, you're a politician. So this is the weight in ounces to the price. What kind of equation is the weight in ounces to the price going to be? Is it going to be a y-intercept? If you buy 0 pounds, is it going to cost you money?
No.
So what kind of equation do you expect? Somewhere around the y equals kx, right? Direct variation. So that lets me know where I start, and then I can quickly put my line so that I make roughly half above and half below, right? You don't understand?
Yeah, I'm a little confused.
Okay. Which part?
How do you draw the line?
How do I know if it's... Oh, that was a terrible...
Yeah.
Does that do it to the orchard?
Yeah, it should have.
Hey, way to try that.
Oh, that's fine.
Yeah, I made a good attempt. Thank you.
Oh, good enough. It's good. Yes, I did.
Okay, there it is. A better line. So, why do we know that it's going to be y equals kx? Because we can say something like, if you buy 0 pounds, it's nothing. Now, if you go in Chris's meat shop, just for walking the door, Chris charges you $5.
What? Keep you making me.
Dude, you got into Chris's door, and now you can Chris doesn't care if you stare all day and say, I think I'll, he doesn't care because you have to pay him $5. Most businesses don't work like that.
No, they're nice.
Rayden's at the door and he says, did you buy anything? No, that'll be $5. What do you mean? $5. Give up $5.
What if you $5 for wasting my time?
Or I'll bounce you back into the restaurant. So we drew a trend line. Let's talk about our equation. What's the first step, Wesley, to get me an equation? Why are you playing with put the board away. Okay, and do what we're doing. Okay, get your paper out. Okay, all right, do you have a trend line on your paper? Okay. Gavin, what's the first step here? How do we get this trend line and find our equation? Find some point that's near a lattice point. How about this one right here? That's kind of latticey. I went right out, way out here.
Oh, okay.
Yours may not be, because remember, our lattice points, because we made a trend line, they're not going to be perfect. You're going to have to make a good, educated, stomping lattice point. I said stomping instead of guess. So, again, what does K equal? Rise over run. So let's get the rise. What's the rise from here to here? If you look at each of these tick marks, what are they going up by?
20.
0.20. So the rise is, well, that actually worked out. So what's the run? Well, 12. Each of these are 2. Each tick mark is 2, right? Can I have a 1/12?
Yes.
Yeah, sure.
Certainly. So my equation is y equals 1/12 x. So the weight per ounce. If I buy 10 ounces, how much is it going to cost me? If I buy 10 ounces,
12.
I can multiply this by it, right?
Yeah.
What's 1/12 of 10 ounces? Well, I can tell you that. It's right there.
It's that.
If I buy 10 ounces,
80 cents.
I'm going to pay around 80 cents, right?
That's
So
cheap.
80 cents.
That's dirt. What if
It doesn't say what we're buying though. We can be
Buying
buying soil. It doesn't really say what we're buying.
I'm buying your videos for soil too.
You get extra points for saying dirt cheap for soil. Okay. So if x is 20, what will be y? If x is 20, what will be y? To do that, we just do y equals 1/12 and replace x with 20. So that's 1/12 of 20.
1 over and 1 in 12. 1 in 12.
Oh, it's so sad.
5 over 3.
I tried.
It's just that. 5
Oh my
over
God.
Oh, wait.
5/3 or 1 2/3, right?
3. Yeah.
So the price would be $1.66 or 67 if we round up like that.
Memorize.
Huh?
How do you just randomly know that?
That's not including
I-
tax.
How many times have I taught this lesson?
Too many.
We don't know.
3 times.
5. Now, 5.
Whoa.
Why would
Well,
you
actually,
be a
no.
math teacher for
I
long?
7 because I had multiple classes of 8th graders.
Like
I would
said,
just
too many.
honestly.
Oh my god, my
Why?
nose is crooked.
Is that like math? Why would you want to teach math for a living?
Because
likes
I
it.
get to see you when you get excited and you get it.
I don't get it.
You do. There are moments, and you can ask your friends sitting at the table, there are moments when you suddenly understand what you're doing, and I can see a happy in your face.
Yeah.
Because you're doing this.
I'm normally always happy.
They're always.